Alright guys, so this is our first problem for the FedEx grant. So there's a 400-pound robot crate and we need to figure out two things. We need to figure out A, how much force it takes to start pushing it up out of the truck, and B, how much force it takes to start pushing it up the ramp to get into the school. Now for the first part, there are a couple of constants that we need to consider. We need to consider gravity, which in imperial form is 32.174 feet per second squared. We need to consider the conversion factor for pound mass to pound force, which is 32.174 pound mass divided by pound force times feet per second squared. And finally, we need to consider the coefficient of friction of the truck bed, which is 0.40. Alright, so the first thing we need to do is we need to look at our statics, okay? So Fx plus Fy plus Fc is equal to Max plus May plus Maz. And basically what that means is the forces in each of the three main directions are equivalent. Now, because it's a flat surface, the only thing that we have to worry about is the force in the x plane. So we're going to go ahead and get rid of Fy and Fz and May and Maz. So we're going to get Fx is equal to Max, or the force in the x plane is equal to mass times acceleration in that plane. However, we also need to consider the coefficient of friction. So what we're going to do to calculate our force is we're going to take the coefficient of friction and multiply it by the mass and by the gravity, because gravity is the force that we need to overcome to push this box forward. So we multiply that and we multiply 0.40 times 400 pound mass times 32.174 feet, and that equates to 5,150 pound mass times feet per second squared. However, we need to convert that because that's in pound mass and we're looking for force. So to convert that, we're going to use the conversion factor we talked about. We're going to go 5,150 pound mass times feet per second squared divided by our conversion factor, and that will give us 160 pound force. So to move that box out of the truck bed, it takes 160 pounds of force to start pushing it. Okay, so for the second part, it's going to be a little bit more tricky. We have forces acting in more than one plane. We have forces acting in the x plane, our force that we want to push it with, and our forces acting in the y plane since it's on an incline. Now before we start, we need to consider the coefficient of friction of the ramp, which is 0.60, the angle of the ramp, which is the maximum allowed by the ADA, which is 4.8 degrees, the weight of the crate, which is 400 pound mass, gravity, which is 32.174 feet per second squared, and finally the conversion factor for pound mass to pound force, which is 32.174 pound mass divided by pound force times feet per second squared. So the first thing you need to do is set it up the same way we did the last one. Fx plus Fy plus Fc is equal to Max plus May to Maz. So we can immediately cancel out y because we're not moving in that plane, so that gives us Fx plus Fc is equal to Max plus Maz. Or the friction due to gravity plus Fx. Now, for the friction due to gravity, that's pretty simple. We're going to use the coefficient of friction times mass times gravity times the cosine of theta. Because if you look at this chart here, our You can see pointing down is the 400 pound mass, and force rather, pound force. And in a way that is perpendicular to the slope, we have our mg cosine theta, which is the actual downward force. And now our normal force is going to be pointing up in the opposite direction as that, giving us mg cosine theta, which is our f of z. So it's mg cosine theta times the coefficient of friction plus ma sine theta, because that's the force we need to calculate to push that box. So if you calculate that, the force due to gravity is 7,700 pound mass times feet per second squared, and our pushing force required is going to be about 1,100 pound mass times foot per second squared. So we're going to add those together, which gives us a total pound mass of 8,800. But now we need to convert it again, because again, this is force and not mass. So we use our conversion factor, 8,800 pound mass times feet per second squared, divided by our conversion factor, and that gives us about 270 pound force. So it takes 270 pound force to move this box up this hill.